Hi all, welcome back to the John Deere B tractor restoration. And in a recent video I did mention that I would do a quick video regarding all things electrical. Now at the moment we're looking, that picture is the back of the dashboard with the wires laid in to the various components. Back of the ammeter, and that unit there is the light switch with the resistor connected to it for the cutout switch and field coils on the generator. Now the wiring loom is a bought one. It's I paid quite a bit of money for it. I think I did say that I could, next time if I do an electrical one, I would try and rebuild the wiring loom myself. I have a company that I know I can use that can supply this sort of replica old looking wire and the cotton sheathing, so I'll probably have a go at making my own the next time. This one is a bought one. It came from the Steiner group out of the USA. It's good quality, I will give it that. It's some of the better quality electrical stuff that I've bought. It's well made, all soldered joints, etc. So I'm quite happy with it, but I would like to try and make my own the next time. Anyway, so moving on. We have the main cable of the deal here. It has 3 light cables in it and 2 cables coming from the generator. The big fat one is the main sort of power feed to the battery. This comes from the battery side of the generator off the cutout switch, goes through the ammeter, through this cable here, which is bolted to the top of the starter motor. The big heavy cable goes to the starter motor, which obviously is this fella here, which then supplies power back into the battery. The other cable is the feed to the field coils on the generator cum dynamo. Now this unit is 6 volt, as I mentioned, and it uses the old-fashioned cutout relay. The difference between the cutout relay and the regulator one is that the regulator system is a upgrade to the cutout relay system. The regulator box is a mechanical means of controlling the electrical charge to the battery, whereas the cutout relay relies on this resistor. I don't know if we can see that on this resistor on the side of the 3-way switch. Now that works in that when the switch is I'll move the camera now so we shan't be able to see anything. Oh dear, come on, settle down. There we go. Yeah. So the resistor works in that when the switch is in the total off position, the current goes through the resistor wire to the fields in the field coils in the generator, and through the magics of electricity, the low voltage it produces in the field coils regulates how much power the output is back down this cable here. When you move the switch into the other 2 positions, the first one being just a general charging position, the resistor is bypassed and the whole system is straight to is grounded, and the power gets full power down this cable to the field coils, which ups the output of the generator. And when you pull the switch fully out and the lights come on, again the resistor is bypassed and the field coils are getting full power, and therefore the generator is producing that extra power to both charge the battery and run the lights. If that makes sense. It all relies a little bit on the driver as well, because he's obviously to some extent will monitor his ammeter, and if he sees it discharging slightly or it needs a good charge, you will then move it to that middle position so that the resistor is bypassed and the battery is being given a good charge from the generator. In general running conditions, you will have the switch right in, and the resistor will be in circuit, and the generator will be producing just a gentle trickle charge to the battery, which in most cases is where you need to be, because if you have it charging too hard, you can come to a point where you will boil the water in the battery, I suspect. Yeah. Whereas with the regulator system, which was the upgrade to this or this cutout switch, etc., that does it mechanically with a set of points, and so the points are continually being closed and shut in the regulator box, and that mechanically regulates how much power the generator is using, and it works on the draw from the battery. So the more the draw on the battery, I guess probably the quicker the points shut and close. So this is a bit more of an old-fashioned system. I mean, the cutout really at the end of the day, on top of the dynamo cum generator, basically all that's doing is stopping the battery. Once the tractor's stopped and not running, it stops the battery discharging back through the dynamo and flattening the battery. And once the engine's running, it's just a big relay coil. Once the engine's running, it closes the relay, which allows the power to then connect back to the battery, and hence the battery will charge. But as I say, when the engine stops, these points open, and it basically is a switch. It just stops the power being drawn back through the battery, and the power being drawn back through the generator and flattening your battery. So yeah, so as I say, that cable there comes from the battery terminal on the cutout relay. This cable here is obviously your field feed on the generator. Feeds the field coils, and depending on where the position of the switch is, whether it goes through this resistor coil here or direct feed from the little bracket on the back here. You have 3 light cables, one left-hand light, one right-hand light there, and this one here feeds the backlight, or the red dual light if you happen to have it on for road work. And this little cable here, you can't just see it, but this coil here goes to the dashboard light. The supply to these lights is this fella, and as in the original system, it has a fuse, inline fuse. So anything should short out, it will blow the fuse. So yeah, it's very much similar to the old-fashioned system that it uses on these 6-volt systems. As I say, the biggest drawback with them is that if you're not careful as to which position this switch is in, you can start to boil the battery. It all depends also on to where. Now, I'm getting a bit more complicated. If we move down here, here's the generator. I'll just bring the torch down. So there's the generator. So yeah, so there's the cutout relay is in that box there. That is a genuine Delco Remy one. The aftermarket ones you buy are, to say the least, wanting. They are very poorly made. I've looked inside them and their contacts, they're just rubbish really. I don't know where they're made, but they could be made better, I think. So this is a genuine one. I managed to find it off a certain internet website. auction site. Paid far too much money for it. But anyway, I wanted it for its looks and all the rest. So there's a big heavy cable that goes to the battery side of it, and there's your field coil cable that again goes to that resistor on the switch. And that cable there goes from your A terminal onto the other side of the cutout relay. So it goes around there onto the cutout relay. Now to polarise these dynamos, generators, I'm pretty sure with this system all you do is, once the battery's on and you're connected up, you get a short piece of wire and jump from that terminal to that terminal. Just flash it over, and the generator will be polarised. Because at the moment, if you recall, with this setup, I'm running a positive ground. So basically, the tractor's all ground. The frame of the tractor is all positive ground, and the negative is what runs in all the cables. Not that it matters. If it was the other way around, that'd be still the way I think you would polarise your dynamo stroke generator. So you'd flash a wire between that terminal and that terminal. Pretty much the same as if it had a regulator on it as well. I have a regulator down here, if I can just get to it. This generator is off another tractor, which I haven't discussed with anybody yet, but we will be discussing it soon. And again, I think you just between the battery and one of these, you would just flash it across, and that would polarise the thing up. So yeah, so nothing too complicated really. The cable that you can see laid here, it's a bit laid all over the place to be fair. I haven't connected that up yet because I haven't fixed that down yet because some of it runs through the hood. So when the hood goes on, that cable, that cable will be laid in a conduit, and so that's why it looks a bit loose at the moment. Yeah, I don't think there's a lot more I can say about the wiring. I have done another video just discussing the wiring system, but there you go. Hang on a second, it'll just don't get drunk. Right, so there's that. There's the ammeter, and there's this switch, and as you can see, so that would be where you would generally run when the tractor's running. If the ammeter isn't showing a big minus figure, you would generally run it there, and it would be trickle charging the battery. If you feel that the battery needs a decent charge, you pull it into that first position, and it will bypass that resistor, and it will be the field coils in the generator will be getting full power, and as I say, through the magics of electricity of a generator, it will be producing a decent charge. And again, when you pull it right out, the lights are on, and the generator will be also producing charge for the battery and helping to run the lights. There is one thing I haven't mentioned in these generators, is that John Deere uses a dynamo stroke generator with what they call a third brush inside here, and that third brush is movable, and that is another method of controlling how much charge you produce, but until you get it actually up and running, you can't really tell where it needs to be, that third brush, other than what your ammeter's telling you. Yeah, I will be honest, I'm not 100%. It's a bit of black magic is alternators and dynamos to me. Very clever picture kit, but yeah, I think you can't get much simpler than these. As I say, there's a brush in there that you do alter, which helps with how how much charge is being produced. So I hope that's about as clear as mud. If there's any questions, if anyone wants to ask me a question, just comment, I'll try and help. But that's roughly where it all works. I know the lights work, I've had the lights on and they work, and all the rest of it, so yeah. Okay then, thank you very much, thanks for looking, bye.